Okay, so this is what yours looks like, right? If we're talking about this translation that we see here, and so so if we're talking about this translation, we have a quadratic, and Richard, what does that plus 3 do to the quadratic? Up 3. And that is a vertical shift. Depends on if it's horizontal or vertical. But for these, we're just doing shifts, so they're up or down, left or right. So it's just going to go whatever number you have there. So you don't have to worry about the greater than 1 or less than 1 for this. So it's just going. So this is just vertical shift up 3 here. But we'll come to that here in a minute. It'll be slightly different, but we'll do that here in a minute. The x minus 5 to the third with the x minus 5 inside of the parentheses. So this is a cubic. And for this cubic, Jacqueline, what's going to happen to it? Good. It's going to shift to the right 5. Okay? Remember, it's opposite direction. So if you have a negative inside of the parentheses, it's going to go to the positive direction. This is a horizontal shift. And so translations move a function up, down, left, or right. All right, we've done all of that stuff before. So now let's look at how this applies to trig functions. Oh, okay. All right, so so for example here, if I have sine of x plus 1, that plus 1's not inside the parentheses. That's just going to translate that sine function up 1 unit. Okay? So what this does is there is a characteristic about the sine function that is really important to us, and that is called the midline. Okay? So the midline is the horizontal line that runs through the middle, and by middle I mean halfway between the max and the min for the graph of the graph. Oh, that should say, sorry, the horizontal line that runs through the middle or halfway between maximum of the graph. So on the graphs that we just graphed for sine, where's your midline at? It's at what equals 0? Y equals 0. Y equals 0 is a horizontal line, right? So, and that is your x-axis. So for sine and cosine, the midline is the x-axis. But if we shift the graph of sine up 1 unit, the midline also goes with it. So this number on the end is going to be your midline. So, oh wait, I need to fill out all these blanks. So if in f of x equals sine x, the midline is y equals 0, or that's also called the x-axis. It's sort of difficult. I know that I, as a student, had a really hard time keeping this straight. X equals a number like x equals 3. This is a vertical line. Y equals a number like y equals -2. That is a horizontal line. So midlines will always be y equals some sort of number. It will never be x equals a number. That would give you a vertical line. So let's look at somewhere we've got to find the midline. Oh wait, no. We'll look at some here in a second. Alright, so we're going to go ahead and look at our horizontal shift. So horizontal shift, for example, we have this example where we've got cosine of x plus pi. And so the cosine function would be shifted to the left pi units in this case. For trig functions, your horizontal shift has a different name. It is called a phase shift. The best thing I can relate that to that helps me remember is the phases of the moon. The phases of the moon repeat themselves over and over and over again. So if you are looking at the phase of the moon, if you were to shift like when full moon was to the left or the right, that would be your horizontal shift. So horizontal shifts can be very simple, like the example I have here. They can also be very complicated, which we will learn about at the end of this section. And when I say very complicated, I don't really mean that difficult. I just mean not nearly as straightforward as they've been before. So we're going to hold off on that. So expansions and compressions. Expansions and compressions were the ones that were difficult. Do me a favor, real quick, and make those negatives right there positives. I have unnecessarily complicated this by making them negatives. It has nothing to do with expansions or compressions. So let's ignore that. Okay. So expansions and compressions I think were much more difficult than the vertical and horizontal shifts. So let's see what we can remember. If I have 3 times the absolute value of x, is that vertical or horizontal? Nope. So obviously it must be vertical, right? How do we know it's vertical? We either had inside or outside, and we have big numbers and small numbers, right? So we know that the expansion or compression is vertical if it's on the outside of the parentheses, or in this case, it's absolute value bars instead. So this is vertical. Everything on the outside of the parentheses works like it should. So if I have a big number like 3, then it's going to be an expansion. So this would be a vertical expansion. By a factor of 3. So Elena, the second one, I've got 0.02 times the absolute value of x. Is what is that one going to be? Very good. Vertical compression by a factor of 0.25. So vertical because it's on the outside, compression because you have a smaller number, a number between 0 and 1. Okay? So if those two are vertical, the next two are going to be horizontal because the numbers are on the inside of the parentheses for these. So both of these are horizontal. Alright, and horizontal, everything on the inside of the parentheses is backwards. So if I have a big number like 2, it gives me a compression. By a factor of what? What do you think, Trevin? What factor? 1/2. Very good. Because it's not just a number, it's got to be 1 over that number. If you got to flip that number, so it's got to be 1/2. So then, Lapita, for the last one, this is going to be horizontal. Is it going to be an expansion or a compression? It's going to be expansion because a small number makes it bigger whenever it's on the inside. So it's going to be expansion. By what factor, Lupita? It's not going to just be 0.5 because nothing on the inside is easy like it's supposed to be. So 0.5 is 1/2, right? So what we do for if it's horizontal, if it's inside, we're just going to flip that fraction. So we'll flip it, it'll be 2 over 1, so we'll just get a factor of 2. Okay, you guys remember doing this? Probably good for us to go back over it a little bit right now, because especially expansions and compressions, I think, are a little hard to keep the rules straight there. So, alright, so, the good news is one of these is what I think is the easiest type of transformation for sine functions. So your vertical expansion or compression, that's what stretches it out tall or squishes it in short. That is called your amplitude. And the amplitude is the distance from the midline to a maximum, or it could be a minimum, it doesn't matter, point. So the distance from the midline to the highest point, or the midline to the lowest point. Midline's in the middle, so those two things should be the same. And so whenever you have a trig function, this number out in front of your sine or cosine function, that is your amplitude. Notice right here, you have absolute value bars around that. You might want to put yourself a note right here. Amplitude is always positive, because a negative would flip the graph. Just like whenever we do expansions and compressions, that factor is always positive because a negative flips the graph. So amplitude's super simple to find. It's just the number in front. So like for this first example, our amplitude is 3. In the next example, our amplitude is 1/2. And for the last example, our amplitude is 130. So whatever number is in front of your sine or cosine function, that is your amplitude. I should make a note, I have used sine for every one of these examples. It does not change any if you have cosine instead. So pretty much everything I'm showing you here works, whether it's sine or cosine. Now, tangent, cosecant, all of that, that's a different story that we'll look at a little bit later. But for sine and cosine, the rules are the same. Okay, questions? Alright, your period is what's going to change with your horizontal expansions or compressions. So your period, remember, is how long it takes for your graph to repeat. So if you expand that horizontally, it makes the period longer. If you squish it in horizontally, if you compress it horizontally, it's going to make that period shorter. So your period, I wrote this on the other one, but it's the distance it takes for the graph to repeat. So, for most horizontal expansions or compressions, we just flipped the factor that we had there. Things are going to be a little bit different for sine and cosine when we're talking about the period of the graph. So the normal period for sine or cosine is 2 pi. It was on that other sheet that we were looking at. Period was 2 pi. So if we have a number in front of our x, this k that we see here, our period is going to be 2 pi divided by k. So where normally we would do 1 over the k, if it was a different type of function, if it was something squared or if it was something like that, for this, for asking for the period, we're going to do 2 pi divided by k. So, for example here, sine of 5x, the period for that graph would be 2 pi over 5. And that will not reduce or simplify, so you're just going to leave it just like that. So in this case, sine of 5x is going to repeat itself every 2 pi over 5 instead of every 2 pi. The next one, our period, is going to be 2 pi divided by 1/2. And you guys should know by now that I do not want you to leave me something like 2 pi over 1/2. That needs to be simplified. So 2 pi times 2 over 1 is going to give you 4 pi. And you'll still see the same trend. If you have a big number like 5, it's going to make the period smaller. If you have a small number like 1/2, it's going to make the period bigger. So that same trend continues. So what it does, I'm going to go to Desmos real quick so we can see what this looks like, because I think that sometimes is helpful. So y equals sine x looks like this. I'm going to go over here and change this a little bit. Negative 2 pi, 2 pi, pi over 4. Okay. So you've got your graph here. This is y equals, actually I'm going to change that. Let's do pi over. Let's go up by. Well, that's fine for right now. If we graph y equals sine of 5x, what that does is it compresses your graph by, it is compressing it by a factor of 1/5, is what it's doing. So that period used to be 2 pi, but now it's 1/5 of 2 pi, which is, so if you look here, here is 0, and then the graph goes along, it's going to start repeating itself right here, and that is at 2 pi over 5. And so it's going to be a lot more squished in, close. You can think of it almost like an accordion whenever you look at that. If we look at sine, or if we do the same with our cosine graph, if we add y equals cosine x, y equals cosine of 1/2 times x. So let me zoom out some for this. The green graph is normal cosine, and you can see that purple graph has been stretched out, right? So it takes a lot longer to repeat itself here. So that's sort of what we're looking at in this case. But as far as figuring out what it is, it is as simple as this rule, 2 pi divided by whatever number is in front of your x. So thinking of what it looks like can be a little more difficult, but figuring out from the equation, it's just 2 pi divided by whatever is in front of your x. So, one thing we actually did not look at whenever we were looking at phase shifts, whenever we were looking at horizontal shifts, is I never made you do a horizontal shift where you also had a horizontal compression or expansion. So I never actually made you do that when we were graphing everything else. But you really cannot avoid it whenever you are looking at your phase shifts and your horizontal shifts for trig functions. So whenever your period is not 2 pi, it affects your phase shifts. So for example, if you have y equals cosine of x plus 2, there is no number in front of that x. You do not have, the period does not change at all. It's still 2 pi. So this would just be a simple shift left 2. So that would be a very simple example. But whenever we look at an example like we have down here, cosine of 2x plus pi, it does not work the same way. So when we have a number in front of our x, we have to do something a little bit different. So what you're going to do is you're going to have a phase shift of c divided by k. So c divided by k. So in this case, we still look at this sign to tell us left or right. So this one's going to be left. Sorry. And we're going to take c, which is this number, pi, but we have to divide it by the number in front of our x, over 2. So left pi over 2. Essentially what you're doing here, you don't really have to know this, but what you're doing is you're factoring out of 2, which would leave you with this 2 times x plus pi over 2. So it is shifted to the left pi over 2. You don't really have to think of it that way. You could just do this number divided by this number. Okay, so if we have this next one, it's still going to be to the left, and I know it's to the left because of this plus sign right here. And then we're going to do 9 divided by just the number in front of the x, which is 1/3. And dividing fractions is easy as pie. We're going to flip the second and multiply. So we'll get 27. So this one would be left 27 units. Okay, so let's look at some where we put these all together. Okay, so we've got to find everything. We have to find period, amplitude, phase shift, and vertical shift for each function. And that vertical shift, I'm also going to add one more thing. I'm going to ask for midline. So I like to start with amplitude. I think it's the easiest. Amplitude is this number right here. It's a 3. I'm going to put some parentheses around that x so we know where it's at. The next thing I like to do is my vertical shift. So vertical shift, because I think it is the next easiest. Vertical shift is how much the graph has been moved up or down. What do I have for this one, Sadie? What's my vertical shift? It is not with the x. Vertical shifts are added to the end of the equation. Added or subtracted. So our vertical shift is going to come from this plus 4, which is going to tell us we got to do what to the graph? Not to the left, because it's not inside of the parentheses. So it's up or down. Okay, so this one is going to go up 4. And that means if it goes up 4 that our midline is at y equals 4. Okay. Your period is 2 pi divided by the number in front of the x. Do we have a number in front of the x? No, so it's a 1, so this is just 2 pi divided by 1, which is 2 pi. And do we have a phase shift? Do we have a number inside of the parentheses here? We do not, so no phase shift. Okay, any questions? Richard, what's our amplitude for number 2? Perfect. Trevin, vertical shift is not. What's the difference between the x minus 3 here and the plus 4, x plus 4 we have over here? It's in the parentheses. So in the parentheses tells us left or right. So does this have anything added or subtracted to the end? It is not. So we have none. There's no vertical shift here. Now, although we have no vertical shift, what's our midline? What equals 0? Y equals 0. So you always have a midline, even if you don't have a vertical shift. If you don't have a vertical shift, then your midline is 0. So you will never say none for midline. Midline will always have an answer. Period of this graph. For the period of the graph, I'm looking at the number in front of the x right here, which I don't have. I just have a 1 there. So the period of this graph has not changed. It's just 2 pi. And so phase shift, for my phase shift, I take this number right here. I divide it by that 1, which I really don't have to do because it's a 1. So I just am going to get 3. And since it's negative, it'll be to the right. Okay. Questions? Alright, we got a couple more to do. So we're going to get to some of them that are a little more difficult. Lapita, what's my amplitude for number 3? It's 2. Very good. Vertical shifts. Let's see. Bethany, what's my vertical shift? There's none. So Bethany, where's the midline? Y equals 0 for that. Good. Alright, now, period. This time I will have a period change because I've got a number in front of my x here. So for the period, I'll have 2 pi divided by that number in front of my x, which is a 2. And so those 2's will cancel, and I'll just have a period of pi. And then phase shift. So for phase shift, you have to take that number that is added or subtracted to your x, and you have to divide it by the number in front of your x. So, Brett, what would be our phase shift for this. Okay, so to find phase shift, we take this number, the number that's left or right, but we have to divide it by the number in front of your x. So 4 over 2, so we'll get 2 for that. Okay, Brett, would that be to the left or to the right? Left, very good. Because we do opposite of whatever sign we have there. Now this one might be a little tricky for you. Amplitude for 4. It is 1. Very good. Always make sure you put 1. Don't put none for that. Okay? Because amplitude and midline, both, you're always going to have an amplitude and a midline. So the amplitude is 1 if you don't have a number in front of your sine or cosine. So amplitude is 1. Vertical shift. Jade, what's our vertical shift going to be? Up 4, very good. And since we have a vertical shift of up 4, our midline, Trevor, what's it going to be? Y equals 4, very good. Okay, so we have our amplitude, we have our midline. For the period for this graph, I've got 2 pi divided by the number in front of the x, which is 3. And then for the last part, for our phase shift, we're going to take that second number, the negative 6, we got to divide it by the 3. So, or we'll have 6 divided by 3, which is 2. And that's going to be to the right. Yes. Yes, always start with 2 pi as long as it's sine and cosine. Now when we get to tangent, it's going to be different. But for sine and cosine, always do 2 pi divided by whatever number is in front of that x. So I do want you to write down something that is not on there. We're not going to do this part yet. We're going to do it tomorrow. So if you will just to the side or somewhere, I'm going to add a new slide here. So somewhere, I do want you to write this down. What is this? I don't want that. Insert. Oh, new slide. Okay, there we go. Okay, so it doesn't matter whether it's sine or cosine. If we have y equals a sine of b x plus c plus d. A, B, C, and D all are numbers. So our amplitude, that always equals A. Our midline, that is always at Y equals Z. Our period of the graph is always 2 pi over B. And our phase shift is always at C divided by B. So these are rules that you can just follow to find all of these. So we didn't quite get finished with all of these notes. That's okay. I did not think that we would. So I'm going to give you page 373. You are going to do 23 through 34. And for all of these, No graphs. Do not graph anything. We haven't done that part yet. So 23 through 34, you're just finding amplitude and period. I do need to tell you something. If you have, let's say you've got cosine of theta over 3. So you've got cosine of theta over 3. What number is your theta multiplied by? It's not 3, right? Because it's divided by 3. So we can think of this as cosine of 1/3 times theta. Don't pack up. There's another page. Sorry. And so that when you see like theta over 3, that is 1/3 times theta. So to find period, you would have to do 2 pi divided by 1/3 in that case. Then you're also going to look on page 383. Well, actually, it's 384 is where it starts. And we are going to do 21 through 26. Okay? Do not graph any of them. Just tell me amplitude, midline, period, phase shift, the things that it asks you for there. Okay, actually, on the first part, it's just period.